Hi dear students, in this video I am going to talk about equivalent weight in the disproportionation reaction. This topic is from the chapter Redox reactions. Equivalent weight in disproportionation reaction. Disproportionation reaction. Students, disproportionation redox reaction. Disproportionation reaction. Disproportionation redox reaction is a redox reaction in which same element will undergo both oxidation and reduction. Disproportionation is a redox reaction in which a same element will undergo both oxidation and reduction. Students, generally equivalent weight or mass, equivalent weight, there is no difference between weight and mass in chemistry. So equivalent mass or equivalent weight of reducing agent or oxidizing agent is equal to molecular mass divided by n factor. Molecular mass divided by n factor. For oxidizing or reducing agents, n factor is number of moles of electrons transferred. Number of moles of electrons transferred. Students, for example, we will take one disproportionation redox reaction. Cu plus is converting into Cu plus Cu2 plus. Cu plus is converting into Cu plus Cu2 plus. Cu plus to 0. Elemental state and oxidation number of an element is 0. Cu plus to 0. That is, it is gaining 1 electron to convert into the Cu0, 1 electron. If it is 1 mole of a Cu plus, it needs a 1 mole of electrons. Decrease in oxidation number is called as reduction. This is reduction. Meanwhile, same Cu is undergoing oxidation. Cu plus is converting into Cu2 plus, means increase in oxidation number is called as oxidation. Minus 1 electron. Loss of electron is also called as oxidation. Gain of electron is called as reduction. Minus 1 electron, which is a oxidation. Students, this for finding the n factor for the Cu plus, let us assume that is molecular weight of Cu is molecular weight, but here atom it is, so that's why we have to take it as atomic weight of Cu is equal to m. Let us assume that is m. Then students, the number of electrons transferred in the oxidation of reaction, let us assume this as n1. n1 is equal to 1. Number of electrons gained in the reduction of reaction, it is n2 is 1. So n factor is equal to n1 multiplied by n2 divided by n1 plus n2. This is a formula to calculate the n factor in the disproportionation redox reaction. Here n1 is the same as n2, but some cases it is different, right? So we will take one more example also, right? Here n1 is equal to 1, n2 is equal to 1. So let us substitute those values. So 1 into 1 divided by 1 plus 1, which is 1 by 2. Then students, equivalent weight of Cu plus is equal to, if its molecular mass or if it is atom, so atomic mass if it is m, divide by n factor 1 by 2, right? 1 by 1 by 2 is 2m is a equivalent weight of the Cu plus in the given disproportionation redox reaction. Students, now let us take one more example. Dear students, let us take one more example. Disproportionation redox reaction. Br2 in the alkaline medium, it is converting into Br minus plus BrO3 minus in the alkaline medium. Students, here let us assume the molecular weight of Br2 as Br2 is equal to m. Then we know equivalent weight is equal to molecular weight divided by n factor. Let us calculate the n factor for the Br2 here. Here it is in the elemental state in the reactant side, right? 0 is the oxidation state. Br minus 1 is the oxidation state. Here in the BrO3 minus, oxygen general oxidation state is -2, -2 into 3 is -6, and for the Br +5 minus 1 is -1, which is same as the charge on the ion we are getting, right? So here 2 bromine atoms are present. Okay, Br2, in one molecule of Br2 there is a 2 bromine atoms. Then here we can calculate for the 2 Br minus. If it is 2 Br minus, charge will be -2. Charge will be -2. 0 to -2 it is going, right? So it is gaining 2 electrons. So let us consider this as N1. N1 is equal to 2 here. Similarly, for 2 bromine atoms in this, 1 bromine plus 5, 2 bromines, because here we have 2 bromine atoms in the Br2. So that's why we need to calculate for the 2 bromine atoms. 1 bromine plus 5 it is. 2 bromines, for 2 bromines plus 10, right? Then number of electrons lost is 10 electrons for 2 bromines, right? This is N2. N2 is equal to 10. N1 is equal to 2. The N factor is equal to N1 multiplied by N2 divided by N1 plus N2 in the disproportionation redox reaction. N1 is equal to 2, N2 is equal to 10, divided by N1 is equal to 2 plus N2 is equal to 10, right? So 20 divided by 12, 4 5s are 4 3s are. So N factor we got it as a 5 by 3. Then let us substitute this value in the equivalent weight formula. Molecular mass divided by N factor 5 by 3, which is equal to 3m by 5. We are getting equivalent weight of Br2 is 3m by 5. Let us substitute the molecular mass of Br2, which is 160. Br atomic mass is 80. Br2 molecular mass is 2 times that of the 80, which is equal to 160. Let us substitute this value here. 3 into 160 divided by 5. So students, on simplifying this, we will get it as a 96. Equivalent weight of Br2 in the given disproportionation reaction is 96. So students, this is a way how we can find the equivalent weight of a given molecule in the disproportionation redox reaction.